The rest of this chapter اللي هو Heisenberg uncertainty principle, we need to get an idea about this principle. That's it. And you have to memorize this after understanding. That's it. يعني موضوع بسيط جدا. Just principle هتلاقيه في last page of lesson 3 عشان لما تيجي تذاكر. ده مش موجود في lesson 2. ده اللي بس الوحيد اللي بدخله في الشابتر بتاعنا او في الجزء بتاع chapter 5 بتاعنا اللي هو اسمه Heisenberg uncertainty principle. From its name, uncertainty principle. It means principle gives you an idea about something they are not sure about it. Yes, Heisenberg found that it's impossible to know the velocity and the position of particles, especially electron. He is talking about electrons especially. At the same time, what does it mean? It means while the electron move around the nucleus, this is the nucleus, proton, positive, and electrons neutral, and the electrons are moving around the nucleus in clouds. Yes, okay, but this is not the problem. While moving the electron around the nucleus, it moves very, 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 very fast. Its velocity is very fast, very high velocity. Okay, so you need to identify the velocity of this electron. Okay, and also because it's very, very fast, it's difficult to find out the position of the electron each time. The position here or here or here and so on. Some devices can measure the position of the electron but cannot measure the position and the velocity at the same time. If you measure the velocity, you cannot find the position at this moment. Or if you measure or identify the position, you cannot find the velocity. Or if you find the velocity, you cannot find the position at this time, and so on. So it's difficult or impossible. Look, it's impossible to know both velocity and the position of the particles, meaning electron, at the same time. That's it. This is the Heisenberg uncertainty principle. I think it's easy, but it's important. Okay. This limitation deals to that the electrons cannot be identified, as I said before, but sometimes they could identify the position only or the velocity only, but both at the same time it's impossible. This is a Heisenberg uncertainty principle. Got it?
Yes, mister.
Today we are going to start chapter 6, which is talking about the periodic table. Chapter 6 talks about periodic table. As you know, periodic table is the table containing the elements. The elements today may be up to 120 elements today. But before that, many tries of scientists they needed to collect these elements in a table. But before that, they were not 120. From long ago, the scientists started to arrange the elements. They were 30, then increased by 60, then 80, then and up to now they are 120. From the beginning, the scientists tried to arrange the elements by a method to be easier to study them according to their properties. The lesson 1 is talking about the organizing of these elements. How can we organize these elements, or how the scientists organized these elements in a table or something like this? They were few elements from the beginning. You know, they were only 13 elements from the beginning. Maybe 17th, year 1700. Okay, it was few elements like copper from the old, very old elements, silver, gold, and some others up to 13. The chemists tried to find other elements. They discovered other elements and they increased after that. And one of the scientists called Dobryner classified them in 3 elements each time. 3 elements each time. For this reason, he called this method triads. Triads means tri means 3. Adds, triads means each 3 elements all together with because they are similar. Yani 3 elements like this, then 3 elements like this, then 3 elements like this, and so on. Okay, so each 3 elements with similar properties put together. These are from the early tries to arrange the elements. At this moment, I remember they were about 30 something elements. Some other scientists tried to arrange the elements by different methods rather than triads. He arranged them according to the properties, as I said. Okay, but by using atomic mass, not atomic number. You remember the difference between atomic mass and atomic number? Please remember that, because we need to explain something related to them. Who remembers the difference between atomic number and atomic mass? Someone tell me. Shabab? Yes, Bilal?
Atomic mass is the average number of the mass of the isotopes.
Yes, very good.
But the atomic number is the number of protons.
Yes, it's the number of protons in the nucleus. They don't know that atomic number is like fingerprint, and each element has its own atomic number, cannot be repeated. They don't know that. They didn't know this at this time, yeah. Okay, but they used the atomic mass for this reason. Atomic mass, it has decimals like this, look, and this. They took the average of atomic mass for the isotopes or like this, but not for the isotopes, because they were in the early years of discovering the elements. At this moment, for example, they took the chlorine and iodine all together, and they took the average of both of them. Yani it's a method not clear to arrange the element, but it's the triads, because chlorine, you know, similar to iodine, because they are halogens. You saw that in grade 9. They found, or Dobryner found, that chlorine and iodine are similar, so we can put the masses or get the average of them all together and put them together in row, for example. Yani, it's not correct method, but he did that at this moment. The scientists tried to find out the method for organizing the element. Why? Why it's important for scientists to find a logical way to organize the elements? Why? Who can tell me? The answer is in front of you. It's logic. Why? Because it's impossible to determine how many electrons looking for, and we cannot study them easily if they are randomly not organized in a table. So it's important to organize them. Like organize anything. Yani, if you are in the school, you cannot put all the students for all grades in one place. you have to organize them in classes. And also, if you are in the same grade, we have to organize you in two classes because we are more than 50, for example, or this. So organizing is important for studying anything. After many trials, a scientist called Mendeleev came and put a table, and he's the first one who put something called periodic law. He put the method for periodicity of the elements. He arranged the elements according to atomic mass, yes, but by repeating the properties in a pattern. You will see the table now. I give you the shape of the table now, but I just give you the idea of Mendeleev. Mendeleev organized the elements in periodic table, okay? Not the periodic table we are using today, but in a table special for him. Mendeleev was a teacher, and he tried to find out a method to organize the elements by the help of his students. They arrange the elements in cards. Each card, like this, card. Okay. Each card containing the name of the element. At this moment, they were about 62 elements like this. اوكي يا شباب معايا ولا ايه؟ معلش
معاك يا مستر.
احنا بنتكلم في شيء كده هيستوري شويه بتاع ازاي اكتشفوا البريود تيبل، فهو عباره عن كلام شويه يعني، فهو هيستوري كده شويه. فالمهم Mendeleev teacher with the help of their students arrange the elements by this method. How he put for in each card the name of the element and some other information about the element like atomic mass, boiling point, density, some properties of this element. Okay. Second element, the name, atomic mass, and some other properties of this element, and so on. Okay. Now we have elements, and each card containing with the name the atomic mass. Atomic mass 1, atomic mass 2, atomic mass 3.2, atomic mass 5.3, and so on like this. And arrange the elements according to this atomic mass and in order. What he did was correct in something, but he failed in something else. This scientist wrote these properties, as I said, okay, for each element in a card and put them in organizing order by increasing atomic mass, as I said. Put them in groups. And this is the old table of Mendeleev in front of you. He arranged them, but he found missing areas or missing parts of his table because not all of the elements discovered at this moment. Okay, he arranged them in rows and put the similar properties in the same row. Put them in rows like this, and similar properties in the same row. Also, he put them in groups or vertical columns. Okay, but he arranged them in rows as well when they are similar. This is Mendeleev. He found that some elements have the same number of atomic number, although they are different elements. So he failed to arrange them. How come? يعني two elements have the same atomic number. How come? This first problem he found. Second problem, he found that one element, X element, for example, has two values of atomic mass, because there are an isotope for this element or two isotopes for this element. It's another problem. The same element, but it has two values, or one value for two elements, element X and element Y. Different elements have the same value, for example, 20 and 20. For example, yeah. Okay, like this. So it's another problem. He know the problems are repeated, but he didn't correct this problem, or he didn't find solution for this problem, this Mendeleev. But he did something very good. How? When he arranged the elements in order by atomic mass, for example, يعني 2, 3, 4. I just give you example here. 5, 6, then 7, then 9. 9 put here. So we have an element 8 but not discovered yet. For example, yeah. Okay. Then 10, then 20. So we have 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. What about all of these elements? Not discovered yet, but he put an area for them up till discovered. That means he predicted some elements not discovered yet. طبعا دي حاجه تعتبر ناجحه جدا بالنسبه له، لان هو تؤخذ ليه يعني، لانه predicted some elements not discovered yet. مش كده وبس. As I told you, he put them with similar properties. مش كده؟ طيب لما يكون عندي مثلا 7 و9 و10 similar properties، طب ما اكيد هيكون برضه 10 او 8 اللي احنا ما اكتشفناهوش ده، و11 مثلا احنا اكتشفناه ده، هيبقى نفس البروبرتيز بتاعت 7 و9 و10. يعني he is not only predicted the missing elements, but also predicted the properties of them which are not discovered yet. فاهمين يا شباب ولا لا؟ يعني قدر يعمل prediction للبروبرتيز بتاعت الاليمنتس دي واللوكيشن بتاعها اللي هي اصلا not discovered yet. لكن هو نجح في حاجات تانية زي عبد الرحمن، زي ان هو بريدكت اللوكيشن بتاعت elements not discovered yet، فساب مكانها فاضي اهو، في اماكن فاضيه كده سابها فاضيه، قال لك دي elements لسه ما اكتشفتش فاكيد هي موجوده، وفعلا لقوها في يوم من الايام بعديه ولقوها فعلا مظبوطه، عمل اللوكيشن بتاعها وكمان توقع البروبرتيز بتاعتها وطلعت البروبرتيز بتاعتها اللي هو توقعها مظبوط. ها يا عبد الرحمن فهمت كده؟
تمام يا مستر.
طيب حد تاني عنده اي استفسار يا جماعه؟ او حد مش فاهم حاجه من اللي انا قلته لغايه دلوقتي؟ الهيستوري بتاع discovering the element او the arrangement of the element. طيب هل انت حاسس انه بيقول لك السؤال هنا why was Mendeleev predictable an improvement over Dobriner's triad classification system and other earlier system؟ لان كان في سيستم ثانيه طبعا غير دوبنر، بس ليه يعتبر مندليف عمل حاجه افضل من المحاولات اللي قبليها؟ لان هو عامل ايه؟ he predicted the existence and properties of undiscovered elements. انا لسه قايل دلوقتي معايا يا شباب، هي دي نقطه مهمه جدا. شباب معايا؟ Why was Mendeleev's predictable an improvement over Dobriner؟ ليه يعتبر مندليف عمل improvement؟ لان هو predicted ايه؟ the existence of properties واللوكيشن طبعا بتاعها اللي هي undiscovered yet. تمام؟ today's predictable بقى شيء تاني، بدأوا واحد اسمه موسلي عمل حاجه اسمها بريدكتيبل بس سموها مودرن بريدكتيبل، وهي organized the elements according to the atomic number. وكده يبقى هرب من المشكله اللي وقع فيها مندليف، انه ما يلاقيش اي اثنين element ابدا ليهم نفس الايه؟ atomic number. Because you know atomic number is the identity for the element. يعني each element has its own atomic number. ما ينفعش يتكرر atomic number بتاع اثنين element ابدا، ولا يبقى element عنده اثنين atomic number ابدا. صح ولا مش صح يا شباب؟ وبلال عرف لنا atomic number فكرنا بيه النهارده، وادينا عارفين الكلام ده من قبل كده. So atomic number is an identity for each element. يبقى كده هرب من المشكله اللي وقع فيها مندليف، انه organize the elements according to the atomic number and each element has its own atomic number. فخلاص بقى هنحط نمبر 1 هنا، نمبر 2 هنا مثلا، نمبر 3 هنا، نمبر 4 هنا، وهكذا. عمر ما هلاقي تكرار بين element و element في الاتوميك نمبر بتاعه، لان الاتوميك نمبر is an identity for the element. وضحت؟ حد يسالني سؤال؟ حد يسالني سؤال يقول لي طب ليه مندليف ما عملش كده من زمان؟ ده كان عمل كده ويريح نفسه بدل ما هو كان استخدم اتوميك ماس وعمل له فشل. At this moment of Mendeleev, he didn't know that atomic number is not repeated for the elements. ما كانش يعرف المعلومه اصلا، المعلومه دي ما كانتش موجوده او معروفه وقتها، ان الاتوميك نمبر ده identity for each element، والا كان استخدمه صحيح من الاول. فمندليف ما كانش يعرف المعلومه دي. تمام؟ فطبعا زي ما قلت لكم هو عمل تيبل بيزد اون اتوميك ماس، ده اللي عمله مندليف، وفي حاجات فشلت معاه بيزد اون ذا اتوميك ماس as I said، ودي البروبلم بتاعته. اي ذا بروبلم wasn't with atomic mass، لكن كانت في الاورجنايزنج باي يوزنج اتوميك ماس. يعني المشكله ما كانتش في الاتوميك ماس الفاليو نفسها، لا كانت في الاورجنايزنج ذا تيبل او باي اتوميك ماس. فالمشكله ان مندليف عمل كده لانه he didn't know that atoms of each element contain a unique number of protons. ما كانش يعرف ان في حاجه اسمها atomic number، والاتوميك نمبر ده عباره عن number of protons، وهي unique for each element. يعني كل element له رقم خاص بيه او اتوميك نمبر خاص بيه. تمام؟ وطبعا بيقول لك افتكر كده النمبر اوف بروتونز هي دي الاتوميك نمبر، علشان كده هيبداوا يستخدموها في البريودك تيبل الجديد اللي هنبدا ناخده ان شاء الله بكره، اللي هو بنسموه modern periodic table of the elements. Elements are arranged in order of increasing atomic number. وده اللي هناخده بالطريقه الجديده اللي انتوا درستوها قبل كده، و هناخدها ان شاء الله بكره باذن الله. اي سؤال لغايه دلوقتي يا شباب؟
يديك العافية يا مستر.
طيب يعني كله واضح؟ تمام. اشوفكم على خير بكره ان شاء الله يا شباب، ولو حد عنده اي استفسار اللي احنا خدناه يقول لي عليه بكره باذن الله بعد ما يكون ذاكر الليسون. اشوفكم على خير، السلام عليكم.